So in the last couple of sections, we've been looking at using square roots to solve quadratic equations. However, it's not always going to be possible to isolate the squared term. So in the next couple of sections, we're going to be looking at different strategies that we can use when that is not possible. So here's an example of an equation where we cannot use square roots. So the equation x squared minus 5x minus 14 equals 0 is an example where square roots doesn't work. Because when we want to use square roots, we want to get the x squared by itself. Well, if I do that, x squared minus 5x minus 14 equals 0. I could add 14 to both sides, but I can't take the square root because I still have this minus 5x here. I suppose I could add it to both sides. That would give me x squared equals 5x plus 14. Then I could take the square root, but the problem is I still have variables on both sides, so that's not helping me to solve for x. So the square root method really isn't helpful in that situation, okay? So here we're going to need to use a different strategy. One other strategy is factoring, and factoring is a really quick strategy when it is possible. So factors are terms or quantities that are being multiplied. So for example, we can write 15 as the product of 5 and 3. So 5 and 3 are factors of 15. So if I write 5 times 3 equals 15. 5 times 3 is considered a factored form of writing 15, okay? So I want to determine what multiplies to x squared minus 5x minus 14. We want to find two algebraic quantities that when I multiply them, give us x squared minus 5x minus 14. Now we've seen that when we multiply things like x plus 2 times x minus 9, for example. Okay, we can use FOIL and multiply that out, the distributive property, and we get some sort of polynomial like this. That's our goal. We're trying to unmultiply so that we can get it to its factored form. So here's the steps that we're going to follow. And let's kind of do a guide on the side here and follow. We're going to factor 2x squared minus 5x minus 3, following these 5 steps that are here on the side. So whenever we factor, we're going to factor the form ax squared plus bx plus c. So whenever we talk about a, b, and c, we're talking about a is always going to be the coefficient in front of the x squared, b is always going to be the coefficient in front of the x, and c is going to be the constant. So if I look at 2x squared minus 5x minus 3, 2 is the a, negative 5 is the b, negative 3 is the c. So a is equal to 2, b is equal to negative 5, c is equal to negative 3. And if that was out of order, the first thing we need to do is rearrange it so that it was in the correct order for us to determine that. I'm going to move this up to the top so it's out of the way there. Okay. Now, we want to find the value of a times c. Now, for this problem, since a is equal to 2 and c is equal to negative 3, a times c is equal to negative 6. Now, we want to determine two numbers that multiply to equal a times c and add to equal b. Now, there's lots of ways that you can think about this, but the way that I like to organize it is with these little X problems, okay? And you may have seen these before. Lots of teachers set it up this way. This is not an algebra thing. This is just an organizing thing. So here's how we set this X up. The A times C number goes on the top and the B number goes on the bottom. So we just figured out that A times C is negative 6 and then B from our expression is negative 5. What we are trying to find is two numbers, one on each side, that multiply to give us the number on the top and add to give us the number on the bottom. And so here's an example of how that would work. Negative 6 and positive 1. Negative 6 times positive 1 makes negative 6, and negative 6 plus positive 1 equals negative 5. Negative 6 times 1 equals negative 6. Negative 6 plus 1 equals negative 5. That's what we're trying to accomplish, okay? Now, these two numbers are what we are going to use to split the middle term, okay? We want to take our equation from having 3 terms to having 4 terms. So our original expression was 2x squared plus 5, or not plus, it was minus, wasn't it? Minus 5x minus 3. We're going to take out the minus 5x. Everything else is going to stay the same. But we're going to replace that minus 5x with minus 6x plus 1x. Okay? We uncombined this middle term. Once we do that, we're going to split the expression in half right after the second term. You'll notice I split it before the plus. Okay, the plus belongs to the 1x term. I cut it off right after the second term ends. And now we're going to look for a greatest common factor from each of these pieces. So what can I divide out of both of those segments? So if I look at 2 and 6, I can divide them both by 2, and they both have an x squared and x. And so if I divide 2x squared by 2x, I get x. And if I divide negative 6x by 2x, I get negative 3. Always bring down this sign. So it's going to be plus. Now, the only thing that I can divide 1x and negative 3 by is 1. That's the only thing I can divide out. And if I divide them both by positive 1, I'm going to be left with 1x minus 3 again. Now, this is exactly what we should get, is a common factor again. If it is factorable, we should get the same factor both times. So the last step, number 5, is to factor out the common factor and then see what's left. If I divide out x minus 3, I'm going to have 2x left. And if I divide out x minus 3, I have plus 1 left. And so here is the factored form of that expression. If I multiply that out, x minus 3 times 2x plus 1, we will get 2x squared minus 5x minus 3. Okay? So that is kind of a long explanation of how to do it. It's a lot quicker when you do it over and over again, but that's the process. So find a times c and b. And then you're looking for two numbers that multiply to make a times c and add to make b. Use that to split the middle term, and then split your 4 terms in half, GCF, GCF, and then pull out the common term. This piece right here where you divide out the GCF, you can do that part in your head. You don't need to write that down, but that's kind of where you'll go from there. Let's do a couple together, and then I'm going to have you try a couple. So, number 1, 4x squared plus x minus 3. So again, we need to start with our values of a, b, and c. So a is 4, b is 1, c is negative 3. So we're going to set this up. A times c goes on the top, so negative 12. B goes on the bottom, positive 1. We need to think of two numbers that multiply to negative 12 and add to positive 1. And if you are unsure, then start with an organized list. 1 times 12, 2 times 6, 3 times 4, 4 times 3. I know that I've got them all because I'm starting to repeat now, okay? So do any of those add or subtract to make 1. Now, why would I get to subtract? Because I need them to multiply to a negative, so I know one of those numbers has got to be a negative. And so I can tell that my numbers need to be 3 and 4 because they're only 1 apart. I need them to add to a positive, so that tells me I need the 3 to be negative. Okay. Now the middle term is what we're going to split up. So we're going to keep the 4x squared and the minus 3, but we're going to split up the minus 3x and the plus 4x. Notice those both get an x on them because they came from an x term. They should always have x's on them. And then we're going to split it in half. Now, a side note, it doesn't matter which order these go in. It might be more convenient to put them in the other order. Maybe you want to put the 4's together and the 3's together. It doesn't matter. You'll get the same answer in the end. I'm going to leave it since I already did it this way. So now I look at what goes into 4 and 3, just 1, and what goes into x squared and x, I can take out an x. So 4 divided by 1 is 4, and x squared divided by x is x. Negative 3 divided by 1 is negative 3, and x divided by x, those divide out. So there's what I get. Plus, what goes into 4 and 3? Again, just 1, and they don't both have x's, so I can't take any x's out. If I divide them both by 1, I'm going to get exactly the same thing both times. Now look what we got, common factor. That's what we should get. So the common factor comes out, 4x minus 3, and the leftovers are what are going to make up my second factor. Now I don't need to write 1x. I should not write 1x. So x plus 1 is what we get. There is our factored form. Now let's kind of talk through number 2 together and walk through it. So let's have you set it up. So see first if you can set up the top and bottom numbers. What should go on the top and what should go on the bottom. Negative 60, 6 times negative 10 should go on the top, and negative 11 should go on the bottom. Now I want you to pause and figure out what those numbers on the side should be and come back when you think you've got them. Okay, if you have a hard time coming up with the numbers, make an organized list. Don't just hunt around. Start from the beginning. So I can divide by 1. I get 1 times 60. Divide by 2. I get 2 times 30. 3 times 20. 4 times 15. 5 times 12. 6 times 10. If I divide by 7, I get a decimal. 8 decimal. 9 decimal. 10, I get 6. That's one that I've already got, 6 times 10. So if I start repeating, I know I've got my list, okay? Now, I need the signs to be opposite because it's multiplying to make a negative. So 1 positive and 1 negative. And I need them to basically subtract since 1's going to be negative to make 11. So that's how I know that the numbers I want are, oops, I didn't mean to erase that, 4 and 15. So 4 and 15, and since I want negatives when I add, I want the bigger number to be negative, okay? So now, split your middle term. Go ahead and write down what that's going to look like. So you should have 4 terms now with 2 x's in the middle, and then chop it in half after the second term. Now you want to do GCF, GCF. So pause your video and do that. Oops. Okay. That's what you should get. Now pull out your common factor, 3x plus 2, and see what's left, 2x minus 5. There are your factors, okay? There are 4 more examples that you should go ahead and do for practice and check your answers in the PDF that is posted on Canvas. But that's where we're going to go ahead and stop for this video, and we'll keep practicing with this in class.